All. So today we are going to talk about linear discriminant analysis. So to start the session, let us understand what linear discriminant analysis is. We all know about normal linear regression. In regression, what is done is based on some past data, we try to predict the future data. In discriminant analysis, the thing done is very similar, but there is a subtle difference between the two. The difference is in case of linear discriminant analysis, in case of regression, linear regression, all the input variables or the independent variables are continuous, as well as the output variables, which are the dependent variables, they are also continuous. But in case of linear discriminant analysis, the input variables are all or the independent variables are all continuous in nature, but the outputs or the dependent variables are categorical in nature. In categorical, they are like steps, say 1, 2, 3, 4. These are the 4 steps. So based on some input variables which are continuous in nature, it can predict whether the outcome is going to be 1 or 2 or 3 or 4. This is just a small example. So this is the difference. So let us learn how to do a linear discriminant analysis using R. Okay, so we have jotted down a small code in R, as you can see over here. It's a very formula called as LDA, which can be implemented in order to do this analysis. So to start with, we have to run this library function called as mass. This is essential in order to learn the function, in order to run the function LDA. Okay, so the outcome of this library mass, let us see what it. So it is done. You can see here. Now we have to use a ready-made data set which is available in RStudio for doing this linear discriminant analysis. It is called as iris. So let us see what iris has as an outcome. So I'm going to again press Ctrl and enter and see. So you can see in this window, I'm just going to expand it for a while. In this window, there it is a data set of 150 total number of data points. It has 4 continuous independent variables: sepal length, sepal width, petal length, and petal width. And it is giving an outcome which is a dependent variable called as species. There are 3 levels of dependent variables in this case. Setosa is one of them, as you can see. The second level is versicolor, and there is a third level which is called as virginica. So this is all about the data set iris. I am again going to minimize this so that we can go to the next step. So now we are going to directly implement the LDA function on this dataset iris. So how this works is, you can see this LDA out is a separately defined variable which is going to store the result of the LDA function. So you are using this arrow. This arrow is pointing towards LDA out. So LDA out is going to be the storing variable. So after running this function, the parenthesis is going to consist of species. What is the outcome like? The outcome of this linear discriminant analysis expected is species, being the output variable, is equivalent to dot. Dot is a shortcut. Instead of dot, you can again write, which is a longer version, what all the dependent variable, what are the independent variables depending on which the dependent variable is going to give you the outcome. So you can also write, for example, the 4 independent variables separately, which are sepal length plus sepal width plus petal length plus petal width, and it has to be followed by a comma, and following the comma you have to mention the data set which you are using, which is iris in this case. So we are going to run this. So it has already run. Now to see what is inside LDA out, we have to write the command LDA out and press enter in this window, and we will automatically get to see that. Is write LDA out and see what outcome it is giving. So this is the outcome of an LDA. The prior probabilities are available in this case. You can see that in the given data set in iris, all the three outcomes, I mean there were three species named as Setosa, versicolor and virginica. So out of the 150 data points, the result, I mean the data was arranged in such a manner that the occurrences were equal in number. Setosa had 50 outcomes. There were 50 Setosa outcomes. There were 50 versicolor outcomes, and there were 50 virginica outcomes. So we are getting this prior probabilities of 0.333 each. So once we are done with the discriminant analysis, what we are going to do is, with the given data which is stored in LD out, this is the outcome of the discriminant analysis, linear discriminant analysis, we are going to do a prediction. Prediction of what? Using the same set of input data, or using the same independent variables, we are going to try and predict the dependent variable this time. And then we are going to compare the predicted dependent variables with the existing prior dependent variables which we already have in the iris data set. So let us do that. For that we have written this command called as LDA pred being that it's a variable. So we are going to use the predict function. Inside the parenthesis we have two things. One is LDA out because that is the variable which is storing the result of the linear discriminant analysis, and comma followed by the data set from which we are going to take the input data, which in our case is iris. Okay, so we are going to run this, control enter. Okay, now we are going to, what we are going to do is LDA pred, we are going to run it once and see what result it is giving us. So we are getting 150 data sets, but it is giving result in the form of LD1 and LD2. We should not be interested in that. We need to find out the values which is being predicted for species for each of these 150 entries data sets. So we are going to use this function called as LDA class, LDA pred, and we are going to define one more new variable called as LDA class, which is going to store the class information of the data set of the variable LDA pred, which we just predicted. So we are going to run this, and we are going to try and see what is the outcome of LDA class. We run LDA class and we are seeing that we are going to expand this window for better visibility. This is showing the serial outcomes for all the 150 input variables of the dataset iris. These are the predicted outcomes. Now we need to compare we are going to minimize this window once again. Now we need to compare the predicted outcomes with the existing outcomes. So we are going to use the table function now. There is a new variable being defined as LDA table, which is going to store the value table inside the parenthesis LDA class, which we just defined, which is going to contain the class variables the outcomes of the predicted data, and comma the other half of the table is going to contain the actual outcomes which is there in the iris dataset. So we are going to run this command now. Let us see what the outcome of LDA table is. So this is the table. We see that out of the 50 results which were predicted as which had an outcome of Setosa are predicted as, out of those 50, all 50 of them are predicted as Setosa. So in terms of accuracy, Setosa, all the results of Setosa are predicted accurately. When it comes to versicolor, we see that out of the 50 that were having the outcome of versicolor, 48 are predicted as versicolor, and the balance 2 are predicted as virginica. Also, when it comes to virginica, we see that out of the 50, the 49 are correctly predicted as virginica, while 1 is wrongly predicted as versicolor. So what we need to do is find out the accuracy level of this linear discriminant analysis that we have performed. So we are going to go to the next line. I think there has been some typo. We are going to define one more variable known as accure, which is a proxy for accuracy. What it is going to do is, it is going to sum all the numbers in this matrix, the diagonal elements of it, and the total number. The numbers which are appearing on the diagonal are correct predictions, while the off diagonal elements are wrong predictions. So this accure variable is going to find the percentage of accuracy of this linear discriminant analysis we just performed. So it is going to do the summation of all the diagonal elements of the LDA table variable which we just created, divided by the summation of all elements in this LDA table matrix, multiplied by 100. So we are going to run this. Now let us see what result is we are getting once we run accure. So it is giving an accuracy of 98%. So we can say that our model which we just created using the linear discriminant analysis using R gives a accuracy level of 98% for the results which are already there, which are predicted from the dataset input variables of the dataset iris. Thank you.